Hello, and welcome to Summarize Science, where we break down complex research into simple terms. Finding lung cancer early is critical for survival, but it's a huge challenge. The current best method, a low-dose CT scan, isn't available everywhere and often gives false alarms, leading to unnecessary stress and extra tests. Standard chest X-rays are much more common, but they're not great at spotting small tumors, especially when they're hidden by the ribs, heart, or other organs. This paper investigates a potential solution, a new technology called X-ray dark field imaging, or DFI. Unlike a regular X-ray that just shows what blocks the rays, DFI measures how the X-rays scatter off of tiny structures. The lungs are full of tiny air sacs that are perfect for this, so DFI creates an image that highlights the lung tissue itself. Just look at this comparison from the study. On the right is a standard X-ray, where parts of the lungs are completely obscured. But on the left, the DFI image shows the entire lung structure clearly, even the parts behind the heart. To test this, the researchers had a clever idea. Using images of mouse lungs, they digitally created and inserted realistic, synthetic tumors with irregular shapes and textures. This allowed them to create a large dataset to train and test an artificial intelligence model. Here you can see the results of that process. The tumors are visible as small dark spots in the DFI image, but are nearly impossible to distinguish in the regular X-ray, especially in the lower lungs. The team then trained a deep learning AI to find these tumors. To see how much DFI helped, they created 3 versions of the AI. One was trained only on regular X-rays, one only on DFI images, and a third was trained on both combined. And now for the incredible results. The AI using only standard X-ray images performed poorly, finding only 51% of the tumors. But the AI using only the new DFI images found an amazing 83.7% of them. That's a massive leap in detection. The combined model was also very effective and had the highest specificity, meaning it was the best at avoiding false alarms on healthy tissue. So, let's quickly recap what this all means. The researchers demonstrated that dark field imaging dramatically improves an AI's ability to detect small, early-stage lung tumors compared to standard X-rays. The detection rate jumped from about 50% to over 83%. What could this mean for the future? This technology could lead to a more accessible, lower-cost screening method for lung cancer. It has the potential to save lives in places that lack expensive CT scanners, making early detection a reality for many more people. It's a powerful example of how combining new imaging physics with modern AI can push medicine forward.